Hey guys, we're going to look at some pictures and use the pictures to get us thinking about the properties of water. Okay, so here's our first idea. Um, Everybody knows what a palm tree looks like. Do we have palm trees in Virginia? Okay, I want you guys to think about that for a minute. Do you see palm trees anywhere in the state of Virginia? All right, and how does this connect to a property of water? All right, believe it or not, we do have palm trees in southern Virginia close to the water in Virginia Beach. So on a map, if we find Virginia on this world map, we are right around well, geez, that's a mess. It's a tiny little map, but right there on the east coast of the United States, okay, is where Virginia is located. And Virginia Beach is on the coast. And that means Virginia Beach is really close to a very large body of water, the Atlantic Ocean. So people go to the beach in the summer in Virginia because they want to go to a beachy place, and palm trees feel beachy. So lots of property owners will bring in palm trees from farther south and plant them outside of Virginia Beach. But they often don't make it through the winter because they're right on the edge of their ability to survive the climate there. All right. So if we think about that, how does that connect to water properties? Well, the Atlantic Ocean is a large body of water and it moderates the climate enough so that warm weather plants like palm trees can possibly survive in Virginia Beach. But you would never find palm trees inside of the United States, like in Kansas or Nebraska or anywhere in the Great Plains, even if it's at the same latitude as Virginia Beach. And boy, I missed the mark there too. It is hard drawn with my finger here on my phone. But if we drew a line here representing latitude, Virginia Beach and Kansas are at the same latitude. But because Kansas is inland and so far away from the moderating effect of an ocean, it's way too cold in the winter for anything like a palm tree to survive. Okay, let's do another one. Okay. Kangaroos. All right, everybody knows what a kangaroo is. Kind of known or famous for their ability to hop around on their hind legs and balance on their tail. As you guys I hope know, kangaroos are only found in Australia, which is an island down here in the Indian Ocean, pretty far south, actually. And kangaroos, well, what do they have to do with water? Well, just like all mammals, kangaroos have to drink water to stay hydrated. And Australia is mostly desert, so that means kangaroos are exposed to some pretty extreme climates, very, very hot and dry. So kangaroos can't sweat, and kangaroos don't pant like a dog. So how might a kangaroo keep itself cooler if it had to be out in the sun, if it couldn't find shade? I want you guys to think about that for a second. Okay. Kangaroos stay cool by evaporative cooling, but they put the moisture on their bodies by licking their forearms. Okay, so kangaroos lick their forearms, and then the sweat evaporates from that part of their body and pulls extra body heat out of their bodies to keep them cool. It's a weird adaptation, and I don't know any other animal that does this. Okay, so that's our connection to a property of water. Evaporative cooling, like you might expect, but not through panting or sweating. Okay, next one. I know most of you have probably at some point in your lives seen a graveyard, and if it was an old graveyard, you may have seen some graves with markers or tombstones that were very hard to read because they're very eroded. For example, if you look at this picture, you can just make out what was carved into this marble, okay, and the marble is literally washing away over time. So how does this picture of an eroding or dissolving tombstone connect to water? Think about that. Okay, give you guys some clues here. Tombstones are sometimes made of marble, and marble's a really pretty stone that's easy to carve, but marble, unfortunately, is a type of limestone, and limestone dissolves very easily in acidic solutions. Okay, next clue. Pollution from cars and factories, and anytime something burns, releases sulfur and nitrous oxide compounds into the air. And these chemicals react with water in the clouds. Okay, anybody thought of an answer? Okay, well, the connection to water is pH. Okay, the pollution lowers the pH of rain from neutral, about 7, sometimes as low as 2.5, which is very acidic. So you may have heard of acid rain. Well, that's the connection to a water property. Pollution can lower the pH of rainwater. And because water is an excellent solvent to begin with, acidic water is even better at dissolving some stones like limestone. Okay, last one, icebergs. Okay, how do you connect icebergs to a property of water? Okay, let me give you guys a few clues. First of all, icebergs form on land. So the only place you can have icebergs being made is where you have glaciers on land. And most of the icebergs that we think of in the Atlantic Ocean are coming from Greenland. Okay, they're actually made by glaciers, and they're rainwater or snow that is frozen and slides off the land and ends up floating in the water. Okay, and I know everybody's seen icebergs. Icebergs are kind of cool because most of the mass of the iceberg is below the waterline. So only a small percentage of the iceberg sticks up above the water. Most of it is underwater. Okay, so that's a big clue. What property of water does this make you think of? Okay, well, we know that ice floats. Ice floats because it's less dense than liquid water. So icebergs are made of ice, and so obviously they float. Plus, it takes a long time for icebergs, because they're so big and so massive and made of ice, it takes a long time for that ice to absorb enough heat from the water around it to melt. So an iceberg may be formed off the coast of Greenland and end up floating way south, like even down off the coast of Scotland or Ireland. You may remember the Titanic hit an iceberg in the North Atlantic in the summer. So that was an iceberg that had drifted south into shipping lanes. All right, so that was some pictures. Hopefully they got you thinking about properties of water. So we will stop there.